Hi, good evening, one and all. Good evening, my dear students. Good evening, all of you. Very good evening. Good evening, Venkatesh. Very good evening. Join fast. Please come join fast. Just we have only 45 minutes. This is foundation course. Very, very useful. Join fast. These sessions are planned to make things very clear to all of you. We are starting from very basic level. Join fast. Also, good evening. Very good evening. Like and share this session. Please inform your friends. Right. Let us start with my introduction. Myself, Venkatesh. My qualification is MTech Computer Science from Kharagpur IIT. I cleared GATE examination with All India rank 22. I had an experience of more than 15 years across the country in training the students in GATE in 3 different subjects: design and analysis of algorithms, engineering mathematics, and discrete mathematics. Welcome to the Unacademy platform. This is the best online platform in India for all competitive examinations. Experienced faculty members are there. Extraordinary faculty members are there. They might those who have cleared GATE examination at least once in their career, and engineering service examinations, JEE crackers. So all the people who are having backgrounds of IITs, NITs, ISE Bangalore, even JEE rankers. So many of the faculty members have extraordinary backgrounds in Unacademy, right? Right. In Unacademy, there are 2 platforms. One is Plus, another one is Iconic. What is the advantage if a student takes subscription in Unacademy Plus? What are the features? One is you will be having many live classes. You will be listening to your favorite teacher. Structured schedule will be there. Test series, unlimited practice. These 4 are the extraordinary features if a student takes subscription in Unacademy Plus. Sir, what about Unacademy Iconic? So again, you are having more facilities. You are having guidelines from experts. Study planner will be there. Personal coach will be appointed to you. And you will be having a lot of questions and answers of engineering service examinations. Okay. Next, what will be the subscription cost in case of Iconic, in case of Plus? And what will be the duration of subscription? Unacademy Plus Law or Unacademy Iconic Law? Multiple subscriptions ఉన్నాయండి. 1 month duration subscription is available. 3 months, 6 months, 1 year, and 2 years. Generally, we prefer or we suggest students as faculty members, we suggest students to take at least 1 year subscription. 1 year subscription. You will be listening to any of your favorite teacher any number of times. Suppose one schedule has been planned from 6 to 7:30 p.m. on one particular day, one subject XYZ. Suppose you are busy in that schedule. So that class can be repeated or that topic can be repeated by some other faculty. So you can listen to your favorite teacher. You can listen to your favorite teacher any number of times. Okay. So you can see the fee structures. For 1 year subscription in case of Unacademy Plus, the fee structure is 22,500. This is not original fee. The original fee is 25,000. But if you use my referral code GVK10, you get 10% discount. So into 25,000, 10% discount means 2,500. So after discount, the final fee will be 22,500. Very reasonable cost. Very reasonable cost. Now, when you come to this Unacademy Iconic, for 1 year, the actual fee structure is 45,000. If you use my referral code GVK10, you get 10% discount. So the final fee will be 40,500. Understand, my dear students? And these are the various payment methods to take subscription in Iconic R Plus. Remember, my dear students, so this is my referral code. Right. Now let us discuss the concept of functions. Yesterday we had a talk about Cartesian product of two sets, relation, function, and how many functions we can define from a set of m elements to set of n elements. Okay, so I recall those points for a few minutes and then we will go back. We will discuss the types of functions, in what way these functions are going to help us in solving many previous year questions on extraordinary topic, that is probability and statistics. Okay, is this my point clear, students? Right. Yesterday we have seen Cartesian product. Suppose we have two sets A and B. A and B. So how Cartesian product looks like? Basically, it is also a set. Elements are in the form ordered pairs, where the first element is coming from first set, second element is coming from second set. Now, the point is, how can you define a relation from set of elements of A to set of elements of B? Just you take subset of A cross B, that becomes one of the relation. So how many such relations we can define from a set of m elements to a set of n elements, 2 power mn? That is based on simple combinatorics formula. Okay. So later on we move to functions. So function మనం ఎలా describe చేయాలి? Look at this. Suppose I have a set A equal to 1, 2, 3, 4. Suppose my second set B equal to alpha, beta, gamma. Now I am going to write few functions from set A to set B. So let us connect like this. Suppose I am writing all these elements in the form of Venn diagram. So this is my set A, 1, 2, 3, 4. This is my second set B. So elements are alpha, beta, gamma. Now I am doing mapping like this: 1 to alpha, 2 to alpha, 3 to beta, and 4 to gamma. This is one of the possible function from set A to set B. So I don't understand what exactly a straight line represents connecting 1 and alpha. Simple way. I told you one simple example yesterday. It is, suppose I have 4 apples. So 3 students are there. In how many ways 4 apples can be distributed among 3 students? So this is apple number 1, this is apple 2, apple 3, apple 4. So student alpha, student beta, student gamma. So apple 1, see, I am distributing means I should not think that there are 3 students, 4 apples are with me. So I can give only 1 apple to each of them so that the rest of the apple can be with me. No, that is not a proper distribution. Is my point clear? So proper distribution meaning ఏంటంటే అన్ని ఎలిమెంట్స్ అన్ని యాపిల్స్ ని డిస్ట్రిబ్యూట్ చేయాలి. అన్ని యాపిల్స్ డిస్ట్రిబ్యూట్ చేయాలి. One apple can be given to only one student. Okay. One student may receive multiple apples. Try to understand. Later, within short span of time, I am going to discuss image, pre-image, domain, codomain types of functions. If I discuss it directly by using mathematical notations, it will not give any beautiness to this session. So let us think in a more practical way by taking general example, then things will be very clear. Generally, what will happen is sometimes a student may change, it may reverse domain and codomain. Sometimes people write alpha, beta, gamma on the left side, 1, 2, 3, 4 on the right side. Then total concept will be wrong. Understand? So whatever the things you are going to distribute, you should write from in the left side. Who is going to get them? They should be written on the right side. That is very important. Okay. Now you can look at this. Apple 1 can be given to alpha, beta, gamma. 4 chances, 3 chances. The same thing happens. Apple 2 can be given to any one of these 3 students. So 3 chances. The same thing happens with third apple. The same thing will happen in case of fourth apple. So it is 3 power 4. It means that, what does it mean is 4 apples can be distributed to 3 students in 3 power 4 ways. 3 power 4 ways. One way I will write. This is one way. This is one possible way. I am going to write second possible way like this. So let us take 1, 2, 3, 4. Let us take alpha, beta, gamma. So I am a teacher. My favorite student is alpha. So I want to distribute all the 4 apples to alpha. What is wrong in that? Now this is also a proper distribution. So proper distribution means it is a valid function. Got this point? Students, talk to me very freely. Talk to me very freely. Understand? The points are very clear. Now, how to generalize this point? Right. Now, I'm going to write like this. One important note. M apples can be distributed to n people or to n students in n power m ways. In n power m ways. Now let me write few more points. Suppose I have a function f from a to b. This is the standard notation we follow in +2 or diploma level or graduation level. Suppose we have a function f from a to b. The first set is called a domain and the second set is called a codomain. So let me write out this point. If f from a to b is a function, then a is called domain and b is called a codomain. And b is called codomain of a function f. That is very clear. Now let me write one more point. This page contains many notes. Attention please. Suppose I have f of alpha equal to beta. What does it mean? Alpha is distributed to beta. So in function terminology, how can I relate alpha and beta? Image of alpha is beta. Pre-image of beta is alpha under the mapping f. So if f of alpha equal to beta, then my point number 1, image of alpha is beta. The second point, pre-image of beta. Pre-image of beta is alpha. The point is clear. Next we will discuss range of a function. Let us say f is a function from a to b. Let f from a to b be any function. Then range of f is denoted and defined as range of f is denoted and defined as, it can be denoted by using 2 different notations. One is r of f, range of f, or I can also represent like this, f of a. So what is f of a? F of x, where x is an element of a. So f of x such that X is an element of A. It means that whatever the elements are acting as images of domain elements, that is nothing but range of the function. That is nothing but range of the function. Is it clear, my dear students? The point is clear. Now I will tell you an example. Suppose we have a function like this. 1, 2, 3. Here my second set is alpha, beta, gamma. 1 is engaged to alpha, 2 is engaged to alpha, 3 is engaged to gamma. Now it is a valid function. Say this is set A, this is set B. Now what is range? Here range equal to, here alpha is acting as image of few number of elements. Gamma is acting as image of few number of elements. F, what is f of 1? Suppose if the function name is f. F of 1 is alpha. So here I am writing, here f of 1 is alpha. F of 2 is alpha. F of 3 is gamma. So these three elements are nothing but part of range. Beta is not part of the range. So this is alpha, gamma. This is my range. I think this example is very clear to all of you. Is this clear? Now we are going to discuss types of functions. Out of those categories of functions, the major important functions which we are going to use very frequently in probability are on1 and on2 functions. Okay, right. Now we will discuss types of functions. Now this is very, very important. Right. Let us talk about first one. The first category name is 1, 1. It is also called as injection. The second category function is called on2. It is also called as surjection. Third one, it is called a bijection function. Fourth one, identity function. Fifth one, constant function. Fifth one is constant function. Now let us describe one by one. So here itself directly I am saying that it is a function. So function lo ivani categories. Let me tell you by general example, or first of all let me define clearly, later we can go through example. Suppose we have a function f from a to b. So when do you say that this function is 1, 1? If different elements in A have different images in B. Different elements in A should have different images in B. In that case, that function will be called as a 1, 1 function. So first of all, let me write out this, and then mathematically, later on, we go through an example. A function f from A to B is said to be 1, 1 if different elements in A have different images in B. If different elements in A have different images in B, then this function will be called as a 1, 1 function. So how to represent this mathematically? So when the people look at the function, can anybody say this is 1, 1 function? My answer is sometimes yes, sometimes no. When it is yes, when it is no. if the elements of A are very limited, if the elements of B are countable, say for example elements of A are 1 2 3, very less number of elements are there in A, very less number of elements are there in B, then by going through mapping I can say whether it is 1 1 or not. Suppose if a function is defined between infinite sets, then it is not a generally it is not a simple thing to discuss 1 1, but generally for our probability point of view, generally we always discuss about finite sets, but in this session we talk about both finite as well as infinite sets. So here look at this. What does it mean is, that is, if A1 is not equal to A2 in A, the different elements with images enti f of A1 is image of A1 is not equal to f of A2, and this should be true for all A1 comma A2 belong to A. So A1 and A2 are different elements of A. What are the images of A1? What is the image of A1? F of A1. Image of A2, F of A2. So whenever A1 is not equal to A2 in A, F of A1 should not be equal to F of A2. But this is not a simple thing to prove it. That is the equivalent statement rasana. This is if f of A1 equal to f of A2 implies A1 equal to A2. Even if you prove this one, you can easily say that the function is 1 1 function. Is my point clear, all my dear students? Any doubt in this? F of A1 equal to f of A2 ante meaning enti? Image of A1, image of A2 both are same. So this is image of A1, this is image of A2. F of A1 equal to f of A2 means image of A1, image of A2 both are same. That means elements should be same. So this line is very similar to this line. So if you want to prove that something is a 1 1 function, take f of A1 equal to f of A2. From that you prove that A1 equal to A2. If the function is defined between infinite sets. అదే ఫైనల్ సెట్స్ మీద డిఫైన్ చేశారనుకోండి, వెరీ లెస్ నెంబర్ ఆఫ్ ఎలిమెంట్స్ ఉన్నాయనుకోండి, suppose the count is very less so that you can easily manage, then by looking at the mapping you can easily identify whether it is 1 1 function or not. Suppose if a function is defined between infinite sets, so this second version is so useful. Okay, second version is so useful. So let me take examples. Suppose I am taking like this. A function is defined from set of real numbers to set of real numbers. What is R here? Set of real numbers. Suppose I am defining a function like this. Infinite set kadandi, mapping cheyalemu. So I am defining like this. F of x equal to 2x plus 5. So what is the image of x? 2x plus 5. Now let us prove that this is 1 1. So here I will take like this. Let f of a equal to f of b. What is f of a? 2a plus 5. F of b is 2b plus 5. So you can cancel 5 on both sides. You will get 2a equal to b. 2 has multiplicative inverse. So I can say that a equal to b. Therefore, I have proved that f is 1 1 function. Now I will go through example number 2. I will define an example between infinite sets only, but in the negative direction. Suppose f is a function from set of real numbers to set of real numbers. The function is f of x equal to x square. Is it 1 1? F of x equal to x square? My dear students, tell me, is it 1 1? ఈ ఫంక్షన్ 1 1 అవుతుందా? f of x equal to x square 1 1 అవుతుందా? Try to answer. Mahesh, Vasu, Harika, Venkatesh, try to reply. No problem. Even if it is wrong, it doesn't matter. F of x equal to x square. Will it be 1 1? Will it be 1 1? No, Vasu, no. Why? Very good, Vasu. Very nice. Why it is not 1 1? Mahesh said yes. ఈ ఎస్ అనేది నాకు రిప్లై వాసుకి రిప్లై అది. If that S is right, please look at this. ఇక్కడ ఈవెన్ పవర్స్ ఉన్నాయండి. సో హియర్ యూ కెన్ లుక్ at this. F of minus 2 is plus 4. Even f of 2 equal to 4. So 2 minus 2 and 2 will have same image. Minus 2 and 2 are different elements, but they are having the same image. So here minus 2 comma 2 have the same image. Therefore, f is not 1 1. This is an example in the negative direction. సో ఎప్పుడైనా సరే మీకు నెగిటివ్గా చెప్పాలంటే ఒక్క కేసు చాలు. పాజిటివ్గా చెప్పాలంటే ఇలా జనరల్గా ప్రూవ్ చేయాలి. రియల్ టైంలో కూడా అంతే కదండి. ఇఫ్ యూ వాంట్ టు బి వెరీ గుడ్, యూ మస్ట్ బి గుడ్ ఇన్ ఆల్ ఆస్పెక్ట్స్. If you want to be a bad person, one bad quality is sufficient from your side. Got it? So this is about 1 1. I will go through one example between finite sets, and later we will see how many 1 1 functions are possible from a finite set to a finite set. Right. Example 3. Suppose A equal to 1 2 3. B equal to, say for example, alpha beta. Now is it possible to define 1 1 function from A to B? Is it possible to define 1 1 function from A to B? ఏ నుంచి బికి 1 1 ఫంక్షన్ డిఫైన్ చేయొచ్చా? చేయలేమండి. ఏలో 3 ఎలిమెంట్స్ ఉన్నాయి. ఈ 3 ఎలిమెంట్స్ ఇక్కడ మినిమం 3 ఇమేజెస్ ఉండాలి. సో సపోజ్ మీకు ఏలో m ఎలిమెంట్స్ ఉన్నాయి అనుకోండి, బిలో n ఎలిమెంట్స్ ఉన్నాయి అనుకోండి. In order to define 1 1 function from set A to set B, the condition should be m is less than or equal to n. Understand my point? This is the condition for 1 1 function. M should be less than or equal to n. ఇక్కడ 4 ఎలిమెంట్స్ ఉన్నాయి. 4 ఎలిమెంట్స్ కి 4 డిఫరెంట్ ఇమేజెస్ ఉంటేనే కదా 1 1 అవుతుంది. సో సెకండ్ సెట్ లో మినిమం 4 ఎలిమెంట్స్ ఉండాలి. ఇఫ్ ద ఫస్ట్ సెట్ కంటైన్స్ 4 ఎలిమెంట్స్, ఇక నా ఫస్ట్ సెట్ లో 3 ఎలిమెంట్స్ ఉన్నాయి. ఇక 2 ఎలిమెంట్స్ ఉంటే 1 1 ఫంక్షన్ ఎలా వస్తుంది? ఐ షుడ్ హ్యావ్ అట్లీస్ట్ 1 more element. Okay, so I am going to take few more elements here. So with this I cannot construct 1 1 function. Right, I am going to do like this: alpha, beta, gamma, delta, like this. Now my question is, how many 1 1 functions are possible from this? Try to answer how many 1 1 functions are possible from set A to set B. How many 1 1 functions are possible from set A to set B? This last 15-20 minutes discussion is more useful. Ikkade probability vastundi. How many 1 1 functions I can define from set A to set B? Number of 1 1 functions. Any guesses? Total number of functions అయితే మీరు చెప్పేయచ్చు 4 cube అని చెప్పేయచ్చు. ఏలో 3 ఎలిమెంట్స్ ఉన్నాయి కదా, బిలో 4 ఎలిమెంట్స్ ఉన్నాయి. టోటల్ నెంబర్ ఆఫ్ ఫంక్షన్స్ విల్ బి 4 cube 64. అయితే 64 లో అన్ని 1 1 ఫంక్షన్స్ అవుతాయని గ్యారంటీ లేదు కదా. ఫాలోయింగ్ మై పాయింట్. సో దేర్ విల్ బి సమ్ లిమిటేషన్, దెర్ ఈస్ ఎ రిస్ట్రిక్షన్. ఈ 3 ఎలిమెంట్స్ కి 3 డిఫరెంట్ ఇమేజెస్ ఉండాలి. రైట్, I am going to construct one example like this. 1 2 3. ఈ 1 2 3 కి ఇమేజెస్ ఆల్ఫా, బీటా, గామా అనుకోండి. This is one of the possible 1 1 function. This is equivalent to like this. So 1 2 3. The second set alpha, beta, gamma, delta. Image of 1 alpha, image of 2 beta, image of 3 gamma. Now this is a 1 1 function. Three different elements ki three different images unnai. It is a 1-1 function. This is the short form notation. Alpha, beta, gamma. The next one I can do like this. 1, 2, 3. Alpha, gamma, beta. This is another 1-1 function. The next 1-1 function I can do like this. 1, 2, 3. So this is beta, alpha, delta. The next 1-1 function. 1, 2, 3. Beta, gamma, alpha. The next 1-1 function. 1, 2, 3. Starting with gamma. Gamma, alpha, beta. The next 1-1 function. Gamma, beta, alpha. So just by using alpha, beta, gamma, I have constructed 6 1-1 functions. Ivanni functions. I think these notations are very clear in terms of mapping. Understand my point? So people are saying 9, others you are saying 3. I don't think so. They are right answers. Let's clarify. Don't worry. ఈ నోటేషన్ అర్థమైందండి? Is this point clear? ఇదేమో Venn diagram representation. This is Venn diagram representation. This is a permutation representation. ఇవన్నీ ఏంటో తెలుసా? 1 కి ఇమేజ్ ఆల్ఫా, 2 కి ఇమేజ్ బీటా, 3 కి ఇమేజ్ గామా. So therefore this is exactly similar to this. So I don't want to represent in terms of Venn diagrams. This is simple for me. Simple representation. ఇక్కడ 1 కి ఇమేజ్ ఆల్ఫా, 2 కి ఇమేజ్ గామా, 3 కి ఇమేజ్ గామా. So here and here what is the difference? Images of 2 and 3 are swapped. So still it is another 1-1 function. So starting with alpha, alpha, beta, gamma, alpha, gamma, beta. Starting with beta, 2 permutations. Starting with gamma, 2 permutations. These are permutations among 3 symbols. But ఇక్కడ alpha, beta, gamma తో ఎందుకు తీసుకోవాలండి? Why don't you take delta? Next time you can start with like this. So when you start with alpha, beta, gamma, you are having 6 1-1 functions. Next you will try with alpha, beta, delta. You will get 6 more functions in the similar way. Next you will proceed like this. Beta, gamma, delta. So you will get 6. So these are nothing but number of ways of selecting 3 elements from the codomain set. So I am going to get the answer. That is in terms of permutations, it is 4p3. Why it is a permutation, not combination? Why it is a permutation? Let me explain more clearly. First set లో 3 elements ఉన్నాయి కదా. ఈ 3 elements కి అక్కడ 3 different images రావాలి కదా. అలా రావాలంటే సెకండ్ సెట్ లో 3 elements సెలెక్ట్ చేయండి. సెలెక్ట్ చేస్తే మరి C వస్తుంది కదా సార్ కాంబినేషన్. Here you can look at these permutations, images. So selection ki okay, but after that we were doing arrangements among those 3 symbols. So therefore the final answer becomes it is 4p3. Got the point, all of you? Right, now I am going to write the conclusion. Note, if mod A equal to M, comma mod B equal to N, where M less than or equal to N, that is definite condition, then the total number of 1-1 functions from A to B equal to NPM. So what it is? N factorial divided by N minus M factorial. I hope this point is clear to all of you. Got it? Once I finish onto functions, I will tell you the practical applications of this in terms of probability. Okay? Don't leave up to 8 o'clock. Next to second category, onto function. Right. When do you say that a function is onto? Suppose I have a function f from A to B. We say that this is onto if every element of second set must have at least one pre-image from the first set. If every element of B means codomain, if every element of B has at least one pre-image in A, then the function is called onto function. What does it mean? Every element in the second set must participate in function mapping at least one time. At least one time. Got the point? So let me write out this. A function f from A to B is said to be onto if every element of B must have if every element of B has at least one pre-image in A. This is the definition of onto function. That is clear. So now what should be the condition in terms of number of elements? A lo m elements unnai, B lo n elements unnai anukondi. If you want to get number of onto function, the condition should be m greater than or equal to n. In case of 1 1, m less than or equal to n. Here it is reverse. Kaunta check cheskondi. First set lo 2 elements unnai. Second set lo 3 elements unnai. ఒక్కొక్క ఎలిమెంట్ ఒక్కొక్క ఇమేజ్ రావాలి. ఈ 2 ఎలిమెంట్స్ కి వర్స్ట్ కేస్ లో 2 ఇమేజెస్ ఇచ్చినా 1 element will be free in the second set. In that case, that will be a function, but that is not onto. We were talking about onto function. Okay. So in that case, this combination doesn't work. So m greater than or equal to n. This always works out. Right. Let us take an example. Suppose A contains 4 elements, B contains 2 elements. Say for example, this is 1, 2, 3, 4. B contains alpha, beta. Now let us see. This is one of the possible onto function. 1 to alpha, 2 to alpha, 3 to beta, 4 to beta. This is one of the possible onto function. Now, how many total functions I can define totally? 2 power 4. Out of these 2 power 4, how many functions are exactly onto? My question is clear to all of you. Total number of functions me 2 power 4 assign. Out of these 2 power 4, how many functions are onto? Matto 16 onto functions kavu. Okay. So here total number of functions is 2 power 4. Now out of these 16, how many are going to be onto? Look at this here. Here 1, 2, 3, 4. Alpha, beta. Now every element is engaged to alpha. Now this is not onto function. In the similar way, I will take this function. In the second case, all elements are going to be engaged to beta. But still this is a function, but are not onto. So this is not onto. I think this is clear, this is clear. So here we have two examples. Just you go to the left side of the screen. You can I drawn a 2 mappings, where in the first case all 4 elements are engaged to alpha. So in that case, beta has no pre-image at all. No pre-image means beta is not at all participated in the function mapping. So that is not onto. In the second case, all elements are engaged to beta. Every element is mapped to exactly one element. So it's a valid function. But alpha is not at all participated in the function mapping. That means alpha has no pre-image. So except these two, in the rest of the 14 cases, except in these two, in the rest of the cases, alpha has to be engaged at least once and beta has to be engaged at least once. Therefore, the number of onto functions here is 2 power 4 minus 2. I think why this 2 is subtracted, that is clear because of these two. Hope students, my point is very clear. The point is very clear. So out of 16, 14 functions are going to be onto. Sir, what will happen if I increase one more element in the second set? So in that case, don't say that 2 power 4 minus 3. That is not true. Now I am going to tell you two formulae. One is for number of elements in the second set as to, one is for general number of elements in the second set. Okay. Note, suppose if A equal to M, mod A means M, number of elements in A is M. Here whenever you write modulus for the set, it indicates number of elements 2, where M is greater than or equal to 2. Then number of onto functions from A to B is 2 power M minus 2. This is very important formula. 2 power M minus 2. Sir, is it true in case of 3 also when the number of elements in B is 3? Now I am going to write general formula. Suppose if number of elements in A is M, number of elements in B is N, where M is greater than or equal to N, then number of onto functions from A to B is given by one very standard formula, sigma k equal to 0 to n minus 1 whole power k into nc n minus k times n minus k whole power m. This is the standard formula to get number of onto functions between from any finite set to any finite set. Of course, number of elements in the first set should be greater than or equal to number of elements in the second set. I think this point is very clear, right? So the rest of the functions in the next class I will discuss for just a matter of 5 minutes. You need not worry about identity function, constant function, bijection. Bijection means it has to be both 1 and onto. Now let us see in what way these are useful. 1 function onto. Let me ask you one simple question. This 2 minutes conversation carefully viనండి. 10 chocolates are distributed to 3 students. అంటే ఫస్ట్ సెట్ లో 10 ఏవైతే డిస్ట్రిబ్యూట్ చేస్తున్నామో అవి లెఫ్ట్ లో ఉండాలి, డొమైన్ సెట్ లో. ఎవరికైతే డిస్ట్రిబ్యూట్ చేస్తున్నామో అవి కో డొమైన్ లో ఉండాలి. సో ఫ్రూట్స్ 10 chocolates, fruits or chocolates, whatever it is, 10 chocolates are with me. I am going to distribute to my students. So 10 chocolates are distributed among 3 students in a class. What is the probability that every student receives at least 1 chocolate? Or I will reduce the number. Chocolates 10 అనుకోండి, ఇద్దరు స్టూడెంట్స్ ఉన్నారు. 10 chocolates are distributed among 2 students in a classroom. What is the chance or what is the probability that every student receives at least 1 chocolate? Then అర్థమైంది తెలుసా? We are talking about onto functions. Is my point clear? So 10 chocolates ఇద్దరికి డిస్ట్రిబ్యూట్ చేయాలి. టోటల్ నెంబర్ ఆఫ్ ఫంక్షన్స్ ఎన్ని? 2 power 10. 2 power 10. ప్రతి స్టూడెంట్ కనీసం ఒక చాక్లెట్ రిసీవ్ చేసుకోవాలి. వాట్ డస్ ఇట్ మీన్? ఎవ్రీ స్టూడెంట్ మస్ట్ బి హ్యావ్ అట్లీస్ట్ 1 ప్రీ-ఇమేజ్. అక్కడ ఎవ్రీ స్టూడెంట్ మస్ట్ హ్యావ్ 1 ప్రీ-ఇమేజ్ అంటే ఎవ్రీ స్టూడెంట్ మస్ట్ హ్యావ్ అట్లీస్ట్ మస్ట్ రిసీవ్ అట్లీస్ట్ 1 చాక్లెట్. అండర్స్టాండ్? అంటే ఇట్ మీన్స్ దట్ ద ప్రాబబిలిటీ ఈజ్ ప్యూర్లీ ఏ రేషియో. So in that case, the number of onto functions divided by total number of functions. Understand? Are one functions అనుకోండి. What is the probability that different chocolates are distributed to different students, different children? So that is one. This is onto. Okay. Right. Just wait for 1 minute. This is Creatrix channel where you can find more than 10,000 members. This is our Telegram channel where you get links of our live classes and notes in PDF format. These are the #1 studies channels, India's #1 studies channels working under Unacademy, Telugu channel. Right here we are now. Electrical Junction, Electrical Engineering Pathshala, Computer Science, SSC, JE. Right. Thank you guys. Thank you so much for bearing me since last 45 minutes. I repeat this last 5 minutes class in the next class. Need not worry. Okay. Thank you guys. Thank you so much. Good night all of you.